So when we set B50 for the brightness of our color, we have cut the brightness of the illuminant in half, and the color we see appears darker. If we set B0, we have turned the lights off, so the color becomes black regardless of the H and S settings. It's black even if S is 0, because a sheet of white paper in a dark room appears to be black. So in simple term, hue refers to a point in the spectrum, like green. Saturation is how intense or washed out that color looks, and brightness controls the color as it would look under various levels of illumination. The nice thing about HSB is that its parameters make it easy to think of particular hues. If you want yellow, you can specify it with a single number H60. With RGB, you would need to specify R255, G255, B0 if you want yellow. If you want a kind of washed out yellow, you would use H60, S50. In RGB, you would need to use R255, G255, B128. The hue for yellow-green is 90, halfway between yellow and green. What about washed out yellow-green in RGB? You get the idea. HSB parameters that specify color seem to be, and I'll use a term often used in software development, better factored for choosing a color than RGB is. So RGB is like assembly code for colors, and HSB is like a high-level language. That's as much as we're going to go into about color management in Photoshop. So now we can specify colors. Now let's look at color swatches, which saves the colors we specify so we don't have to hand mix one every time we need a color. A color swatch, as the name implies, is a preset piece of color that you can use when you need to choose a color. We saw color swatches in earlier examples, but we didn't use them. For example, when you use the rounded rectangle tool, you can use color swatches to choose the fill and stroke colors. When you click on the fill color, the flyout shows you a palette of swatches. There is a standard set of swatches built into Photoshop. You can restore that set from the little gear in the upper right-hand corner of the flyout. Click on that gear and choose Reset Swatches. You can add the built-in swatches to the flyout or replace them completely. Click on OK to replace them. You're also given the option of saving the current palette to a file. We'll be looking at saving palettes later, so we won't save them now. You select a color by clicking on a swatch. At first glance, the palette might appear to be a hodgepodge of color selections. Well, by default, the swatches are rather small thumbnails in the palette. You can use the gear in the upper right to change that by selecting large thumbnails. You can also make the flyout larger by pulling on its lower corner. The colors might still appear to be a hodgepodge, though. Use the gear to change the presentation to small list. Now there is an obvious order to how the colors are arranged. The first 6 colors are colors from the color wheel we just saw in order of their hue. That's followed by white to 50% gray in 5% increments. The next 6 colors look sort of like the first 6 colors, but all their names start with CMYK. These are almost the same colors as the first 6. Let's make a rectangle that uses the first red as a border and the second red as a fill. Notice that the presentation mode of the swatches is kept track of separately for the fill and stroke. Depending on how well your monitor is calibrated, the fill color should seem a bit darker than the stroke. Earlier in this video, when we did a discussion of color in general, we said that computer screens can produce most of the colors in the sRGB color space. The border of the rectangle is the reddest red in the sRGB color space. The second set of colors is from a different color space, the CMYK color space. Printers typically cannot print all of the colors in the sRGB color space, but they can do a reasonably good job of printing the colors in the CMYK color space. The fill of the rectangle, which is CMKY red, is the reddest red in the CMYK color space, and is, in effect, the reddest red you can print, but it is not as red as the reddest red you can show on a computer screen. If you print this image, after the ink dries, you will probably be able to distinguish the border from the fill, but the difference won't be anywhere near as pronounced as it is on the computer screen. In fact, here is a picture taken with a camera of that printed rectangle. You can see it appears darker than the rectangle we drew with Photoshop. That's mainly because the stroke of the rectangle used the reddest red that sRGB has to offer, but the printer was incapable of reproducing it. We can explore these colors by the numbers by using the Info tool. Its icon is on the tool panel on the right-hand side of the screen. If you click on it, the info tool flies out. It reads by the numbers RGB and HSB of the color under the cursor. If the panel isn't showing RGB and HSB color numbers, click on the list menu icon in the upper right-hand corner and choose Panel Options. Make the first color actual color and the second HSB. When you float the cursor over the border of the top rectangle, you will see that the hue is red, that is H0, with 100% saturation and brightness, the reddest red. That's the sRGB red we chose from the top of the list of color swatches. When you float the cursor over the border of the bottom rectangle, the hue is also red, H0, and the saturation is 100%, but the brightness is only 79%. That's because the printer is not capable of printing this color at 100% brightness, so it is converted to a brightness it could print. We filled the top rectangle with the red we chose from further down the list of swatches, the CMYK red. This is a red most printers can reproduce reasonably well. The hue is 358, which is very close to being precisely red, but the saturation is 88% and the brightness is 93%. Checking the fill of the bottom rectangle, we see that the hue is 0% with 100% saturation, but is only about 82% brightness. That was my printer's estimate of the best way to reproduce the red fill from the rectangle we drew in Photoshop. So it's about the same as the border, but a little brighter. The point of this exercise was to show two things. One is that even though you will be working on your computer screen in the sRGB color space and might end up choosing printers that a printer cannot reproduce precisely, something that is red or green or whatever on your screen will still be red or green or whatever when you print it. Also, when you choose colors, keep some distance between them to ensure that if your drawing is printed, the difference will be apparent. We'll talk more about that later. If you really need precise colors, as an artist or photographer might, this technique will not work for you. But for the kind of things we as developers use our technical drawings for, it is quite good enough, and it lets us stick to sRGB so that on-screen viewing of our drawings will be bright. If you try this test out yourself, depending on your printer software, you want to configure your printer for its best output. You may also be given a choice for a printing intent. This is selecting the algorithm that will be used to convert the sRGB colors you see on the screen to the colors that the printer can best reproduce. Picking that setting is important for precise color control, but not so much for the typical kinds of technical drawings we make as developers. Oh, and one more thing. If you look behind the curtain, you will see that what I am showing you is taking a big chunk of artistic license. The rectangle was printed on ordinary paper, not the type that would be used if precise color control was required. The image was taken with a digital camera, and its output needs quite a bit of processing to correct its color and brightness. If you hold the actual printout I made up next to my computer screen, the printout and screen image of the printout will be similar in color and brightness. But that's only because I've adjusted things to make that the case so that you would have something to look at in the video. See, when you're working with color, it is just never what it seems to be, and if you want to be precise, everything gets complicated. It's a good thing that as developers, we don't really need precise color management.